But now this is another part from ionic equilibrium. And that is about the pH scale. Actually, this pH scale was given by Sorensen. But a pH scale means we can say if pH is equal to 7, then the solution will become a neutral. And if it is greater than 7, 8, 9, 10, 11, 12, then the solution is a basic in nature. And less than 7, then it is a acidic in nature. For acid, get the square bracket H plus, which is called as a concentration of H plus. Indirectly, it is a normality of acid. And for base, get the square bracket of OH minus ion, that will be called as a normality of base. But this is a relation is there between the normality and the molarity. Normality equal to molarity into valency factor. Valency factor means number of replaceable H plus ion for the acid, OH minus ion for the base, or the total number of positive negative charge on the salt. For acids, as we know concentration of H plus, so we can get the pH. pH equal to minus logarithm to the base 10 concentration of H plus ion. And when it is a bases are there, that is OH minus ion, we should get the POH, that is negative logarithm to the base 10 concentration of OH minus ion. This pH and POH we can join together with the scale called as a pH plus POH equal to 14. Means if we know the pH, we can get the POH. If we know the POH, we can get the pH. For this one, these are the some requirements are there. Everybody should know the value of these log values. What is that? Log 10 is equal to 1. Log 1 equal to 0. Log 2 equal to 0.3010. Log 3 equal to 0.4770. Log 4 is equal to, leave it. Log 5 is equal to 0.6990, which is approximately equal to 7.7. You know, log 4 can be written as log 2 square. That can be written as 2 log 2, 0.3010. And you solve it, the value which we are getting as a 0.6020 is the value of log 4. Is the value of log 4. So these are the few values to remember here. And one more important point is that as the concentration of H plus ion increases, because we know concentration of H plus is directly proportional to acidic strength, which is inversely proportional to the pH. And at the same time, as the concentration of OH minus ion is there, it is directly proportional to the basic strength, which is inversely proportional to POH. So we can say now, as the concentration of H plus value increases, acidic strength increases, but pH decreases. Lower the pH, greater the acidic strength. Lower the pH, greater the basic strength. And based on that, we can say now, if the pH value is equal to 7, solution become a neutral. pH value, if it is less than 7, solution is acidic. pH is greater than 7, the solution is basic. We'll go with some examples how to calculate the pH of the solutions and all. Let us say find pH of the following. But here, suppose I will tell you I am having concentration of H plus value 10 to the power of minus 3 normal they give. How to get the pH? Let us see two method is there. pH equal to minus of log of concentration of H plus and substitute the value of concentration of H plus in this one where we are getting minus into minus plus 3 log 10, and as we know log 10 value is 1, so pH is equal to 3 direct. But one more alternate method is there, that is a shortcut method, and please try to learn this alternate method also. Concentration of H plus ion is equal to 10 to the power of minus pH. This is also one of the formula. Compare this formula with concentration of H plus is equal to 10 to the power of minus 3. But these equation and these equation just to compare, H plus common, 10 common, minus minus common, directly we can say pH of the solution is 3. Suppose if the same question they give in this way, HCl solution has its concentration is 10 to the power of minus 3 molar. See, solution is HCl, means directly concentration of H plus is given 10 to the power of minus 3 molar. But we know molarity must be converted into normality. So normality equal to molarity into X. Molarity is given 10 to the power of minus 3. How many H plus ion HCl can replace? So we can say 1. That also 10 to the power of minus 3 normal. So this is a 10 to the power of minus 3 normal, and directly pH equal to 3. But if this solution, instead of that, if they give in this way, instead of HCl, suppose they give H2SO4 solution, concentration is 10 to the power of minus 3 molar, means convert into normality. Molarity 0.3 into X is 2, because you know this sulfuric acid can replace 2H plus ion. So X value is 2. So normality I got 2 into 10 to the power of minus 3 normal. That is a concentration of H plus. And now we can use pH equal to minus of log of concentration H plus minus of log of 2 into 10 to the power of minus 3. But it is something log A into B can be written as a log A plus log B minus of log 2 plus into minus of log 10 to the power of minus 3. Here minus of log 2 minus into minus plus 3 log 10, log 10 value 1 3, and here I am getting 0.3010. 3 minus 0.3 become 2.7 is the pH of the solution, right? Because whatever the acid or anything they give, the concentration once they give in the molarity, first one is we have to convert into its normality, and that normality, if it is acid consider H plus, and if it is base consider OH minus. If it is H plus get the pH, if it is OH minus get the POH. Example number 4 also I want to discuss here. See, now They give the concentration of OH minus. Let us say concentration of OH minus is given 10 to the power of minus 4 normal. As it is a 10 to the power of minus 4 normal, directly we can say POH is equal to minus of log to the base 10 concentration of OH minus, that is a 10 to the power of minus 4 plus 4 log 10 value 1. You know, POH is 4. They are asking pH. We know the scale. pH plus POH equal to 14. pH equal to 14 minus POH. pH equal to 14 minus 4. pH equal to 10. That is the pH of the solution. If the same thing they give in this way, we are having NaOH solution whose concentration is 10 to the power of minus 4 molar. If NaOH is there and that to be concentration molarity, they give convert into normality, that is equal to molarity into X. As the molarity is 10 to the power of minus 4, X is the acidity of the base and it can replace only one OH minus. So it is 1. I can say 10 to the power of minus 4 normal. So this is nothing but the concentration of OH minus. So we can say concentration of OH minus is 10 to the power of minus 4 normal. And you know one more formula is there. OH minus ion equal to 10 to the power of minus of POH. Compare these two equations. OH is common, 10 common, minus common. Hence we can say POH equal to 4. So pH equal to 14 minus 4 equal to 10. Or we can use this formula also. pH equal to minus of log concentration of OH minus and substitute the value of OH minus and solve it. We'll get it. But now, same question I want to write in this way. I am having calcium hydroxide solution whose concentration is 10 to the power of minus 4 molar. So first, normality equal to molarity into X. Molarity is 10 to the power of minus 4 and X is the 2 because this calcium hydroxide can replaces 2 OH minus I. So normality I am getting as a 2 into 10 to the power of minus 4 normal for base means it is a concentration of OH minus ion. Then get the POH minus of log 2 into 10 to the power of minus 4 minus of log 2 plus into minus of log 10 to the power of minus 4 minus 0.3010 plus 4 log 10 value is 1. So 4 minus 0.3, 3.7 is the POH. But now I will tell you one shortcut method to solve this kind of the numerical. What is a shortcut method means? Suppose if we are having a POH equal to minus of log 2 into 10 to the power of minus 4. Just do one thing. Whatever thing we are having, see 2 into 10 power of minus 4. Directly power should be written as a plus. Minus of this thing should be written in this way. 4 minus 0.3010. It becomes 3.7. It is a POH. But they asked to get the pH. Obviously, 14 minus 3.7, right? It become a 14 minus 3.7. If you do, that means 14 minus 4, it become a 10. Now it become a 9.3 because 7 plus 3, 10, 0, 1, 10, 9 plus 1, 10 plus 3, 13. Sorry, beta. It is a 10.3 is the pH of the solution. Same way here also, POH is 3.7. So I will get pH equal to 14 minus 3.7. 10.3 is the pH of the solution. This is the example of a base and all. No, but in all these examples, we are getting the round figure. Now we'll see some values we are getting in the fractions. Example number 7. I am having concentration of OH minus ion is 3.6 into 10 to the power of minus 5 normal. How to get the pOH? See, direct formula. pOH equal to what is the power we are at? Because just now I told you one trick here, right? Same way. Concentration of OH minus ion we are getting here means we can say the formula of pOH. What is that? pOH is equal to minus of log here to the base 10 concentration of OH minus. Whatever the value is there in 10 ki power, that should come outside, minus of log 3.6. But how to get the value of log 3.6, right? For getting the value of log 3.6, again separate calculation will be there. So approximate, if you want to solve, we can solve it. But you know log 3 ki value, log 3 is 0.4770 and log 4 is 0.6020. In between these two values, 0.47, 0.6, we'll take 0.5. So approximate 0.5. pOH I am getting 4.5. So pH is equal to now 14 minus 4.5. It become a 9.5 is a pH, right? Because this is approximate which one I have to take in here. So this is a way to calculate the pH and pOH.